What's up? Does anyone want to play last session of the day bingo? Bingo cliche? I'm the only thing between you guys and a beer. I'm the only thing. Sorry, just kidding. So can I have a show of hands here? Who here has an electric car? Nice, nice. I see some hands coming up. Who here has a Tesla? Oh, hard luck, guys. So sorry. Okay, no, I'm just kidding. I'm just kidding. All electric cars are fantastic. So yeah, look, I'm gonna go through a couple bits and pieces today around building your own map server. And my use case is building an electric vehicle charging map on top of that. So I'll set a few things out for you. I'm not suggesting you turn off Google Maps, never use it again, run all your stuff off your home kit, and forever have a self-sufficient map server. What I'm trying to do here is show you some of the features and functionality that's available with Postgres, PostGIS, and other open source software that you can build all yourself on your own kit. No licensing, no cost, no nothing, and show you the power of some of these tools. So a few little introductions, very, very, very super quickly. I'm Lizzie, as you can see here. The only important thing to know about me is I love Lego and I love my gardening. But I've been working on the vendor side for just under 2 years now. Before that was on the user side for many, many years. ETL pipelines, system analysis, data architecture, you name it, I've done it. I work for EDB. Just to tell you who EDB are, we contribute a majority of the code to open source Postgres. We provide support for Postgres running absolutely anywhere, and we have various software services tools around Postgres. Basically, you want some Postgres, we got you covered. So to Postgres itself. So thankfully, I don't normally need to give an introduction to Postgres to a data engineering audience because Postgres is very popular in the data engineering space. So I don't normally need to go into any of this stuff. The one thing I will point out is that what we're going to focus on today is the extensibility of Postgres. So the reason why PostGIS was able to be built on top of Postgres is it's a really flexible, extensible, amazing integration relational database management system, and it can do things that other database systems simply can't do. So you've got user-defined data types, you've got user-defined indexes, you've got flexibility with APIs, and all of this stuff comes together with PostGIS to create a massively powerful spatial data extension to rival things like Oracle Spatial and ArcGIS and QGIS and Esri, but it's all open source. It's all completely open source. So PostGIS has been around for about 20 years now. Came out of Canada, a little company out of Canada decided to build it on top of Postgres because there was nothing else that could do that job. And it's actually, I think, kept Postgres going in the times when maybe, it wasn't quite enterprise ready, wasn't ready for those mission critical use cases. The spatial data community was still out there using it for spatial data cases because it is that powerful. So I'm going to go into a couple more of the little bits that we're going to use to build the map today. So first of all, the data itself. So my mapping data today is coming from OpenStreetMap. So OpenStreetMap is a widely available open source mapping data set. It's community built. It's been around for many, many years. It's very widely used in a lot of commercial settings. So Apple use it. We've got Facebook using it. Tesla, interestingly enough, use it for their mapping and navigation in the cars. I don't know if any of you guys have played Pokemon Go at all, or any of the Niantic games, but those maps that they use are all based on OpenStreetMap data. So these are really fantastic data sets for building your mapping server with. Just a couple of things to bear in mind as we go through. So I've got some of the data types listed there. So we're talking nodes, which are specific points, ways, which are lines between specific points, things like relations and tags, which are for building metadata. We don't need to go too much into that right now, but this is just kind of to put it in your head that this is the data that we're building our server with. I keep clicking the wrong thing. Sorry, guys. I should just use the Just use the keyboard, really. Okay, so what do we need to start with? So we're setting up, so I'm not going to actually set up the underlying infrastructure and the server today because that would bore the crap out of everybody. But effectively, what I'm showing here is you can see on the left, this is the list of all completely open source software that I use to build this server. So we set up a database, a Postgres database. We install the PostGIS extension on there. Then we're using an open source tool called OSM2PGSQL to load that data into the Postgres PostGIS enabled database. And then we're going to use Apache to serve that data up. And we are using a tool called RenderD. And what that's going to do, that tool is querying the PostGIS database, all of the mapping data that's in there, and it's rendering it onto the actual browser screen that you're going to see. So what I'm doing here, it's not a mapping background that I'm just putting data on top of. The actual map that you see is all stored in Postgres. So let's have a look at that. So I'm just going to flip over, guys. So this is, now you'll have to excuse, because I can't, the resolution makes it a bit hard to see on the screen, and you'll also have to excuse my crappy formatting. This is just how I do things. But this is my file that's got my JavaScript layer written into it. So that's going to come out on top of the rendering. So let's go over to the map server. So I'm just going to show you guys that this is live. So we're going to look at Sydney here. And like I said, this is just my map. This is my map, fully self-sufficient, coming straight out of Postgres. So we can keep zooming in there. You can see very detailed, usual stuff you'd expect from a map. So the first thing we're going to do, if we just flick through here, these are screenshots that I had to on there in case it didn't work. The first thing we're going to do is we're going to put in a little marker for home. Now, so just to explain a little bit more, we're also using Leaflet here. So Leaflet is a JavaScript layering tool that allows you to put data point, using GeoJSON, put JavaScript data on top of your map to represent your spatial data, things like your points and your ways and all that kind of stuff. So just going to do a really little simple one here to start with. This is just going to put a little marker on where we want to do our home point, where we've got our electric car stored. So let's just go back there. And you can see that's just put little marker, nothing complicated. We're just going to put that in to mark our home base. So that's where our electric car is currently sitting. So what do we want to do? So we're talking electric vehicle charging stations, right? So the first thing we need to do is get some data into our PostGIS database to show where the charging stations are, right? So one of the things about spatial data is it's quite complicated in the sense that there are different spatial reference data types. So if you consider, the difference between mapping the world as a map, like Euclidean style, or mapping the world as a sphere, coordinates actually kind of mean different things depending on the different system you're using. So a coordinate in itself, your normal latitude, longitude, is not actually a spatial data type, at least not as far as spatial reference systems are concerned. So the first thing we have to do is put that data into our PostGIS database, but we enable it to be part of the spatial reference system. So this is super, super easy with PostGIS. There's a very simple transform function to do it. So we just load our data into a normal Postgres table. So you can see there we've got a creating table, and we do our import, which is just from a basic CSV file. We've put that into another table. And now you can see this is the inserting data into stations query. And what we're doing is we're setting that longitude and latitude to be a spatial data type. So you can see underneath in this table here, the geometry type that's in that third column there, that is the spatial data types. And that now is the equivalent of a point data. So what we're going to do now is we want that to appear on the map, right? So we can actually see our charging stations, see which ones are available, see where we're going to go. So the other thing that PostGIS is really good at, it's really good at translating spatial data into other data that other systems can use. So in this example, we're going to use GeoJSON data, because that's what our leaflet JavaScript layer is going to read. So we're just going to do a really simple query to translate that point data to GeoJSON data. I got you guys. Okay, this is actually quite a large stored procedure here. I'm not going to go through all of this today, but effectively, it's still very easy to use. You just hand it over. For example, I'm going to do a polygon, just a square polygon, and I'm going to get out the data that is the charging stations that are within that area. So for example, you're loading a map, you've got the boundaries of the screen. That's effectively what we're doing here, and we want to bring back the charging stations that are in that part of the map. So when we give that over to PostGIS and we say bring those out as GeoJSON, this is the kind of data that you're going to get out. Just really simple JSON data, already prepped, all got the data in there. And I'm just going to show you guys that that is in my file here. So get rid of those comments. So you can see I've literally just taken that data and dumped it straight into my leaflet layer, just the GeoJSON data. So let's go down here, just get rid of those comments, save that file. If anybody gives me grief for running as root, we can talk outside. So let's have a look. So let's refresh that page. Alrighty, let's go. Yeah, cool. So now you can see that all these points are the charging stations that are on the map. So again, that's stored in PostGIS. We've brought it out as GeoJSON data and we've represented it on the map. You can, of course, do all this live using something like PHP if you want to do the interactive map dropping around and that kind of stuff. I didn't really have time to do a full PHP server demo for you guys today as well. But yeah, this can very easily be interactive too. So the other thing, so let's go through a few little things. So what do we want to do with charging stations? So a couple of things we want to know. We want to know where our nearest charging stations are. We've got that. And we want to say our car's got 60 kilometers left. Our solar power has been rubbish for a few days. We're in Sydney, it keeps raining. What are you going to do? So we've got no power. We're going to have to go to a charging station. So which charging stations are within 60 kilometers of our home base? And we can do that query with PostGIS. It is super easy, barely an inconvenience. So let's go and have a little look-see. This is a very simple PostGIS query. It's using the within function, and all we're giving it is the coordinates to our home base, which we put on the map, and we're asking for those stations that we have in our data, which ones are 60 kilometers away. So this is all very standard SQL stuff. It's not particularly complicated. Basically, PostGIS is doing a lot of the heavy lifting for you. So that's quite nice. We like that. If you wanted to know, for example, which are your nearest charging stations and how far they are away, again, this is another query that will do that for you. So this time we're using the distance function as well. Very simple, passing it the point data, and it's just bringing back on that side the distance data. Now, we've also brought back the type of charging station because, we might want to avoid the Tesla ones, you never know. So there you go, that's the data, including the metadata as well. Again, very easy to translate this to GeoJSON, but we've already got our points on the map, so we won't do that bit. So what's the next thing we want to do with this? So we know where our stations are. We know where the nearest one is. We've decided we want to go there. We need a route, right? We need a route. Now, again, don't worry, we're not trying to rebuild Google Maps here, but this is just an example of some really, really powerful functionality in Postgres. We have an extension called pgRouting. Now, pgRouting, what it does is it creates a network topology on top of your spatial data, which is basically a very, very fancy way of saying it notes the point that you have, your literal point data, and it notes the ways, which are the lines between the points. Now, what does that sound like? It sounds like nodes and edges, right? And you'd be right, it's exactly that. This is nodes and edges. So what pgRouting is going to do is going to take our data set. We're going to use another open source tool called OSM to pgRouting. And it's just going to analyze all of that spatial data. And it's going to create that network topology on top of our data. So what that's going to allow us to do is then go in and say, I want to go from this point to this point. and I want the best route of how to do it. And it's going to take all of those nodes and edges, all of that data, put it in another function, and it's going to give us an actual route. So let's have a look at how we do that. This is a list of actual steps required to set up pgRouting with your data. It's actually quite simple, and again, all of this stuff is open source. The only thing I would say to bear in mind is pgRouting can choke a bit on massive data sets. For example, if you were trying to import the entire world, let's maybe not do that. But smaller data sets for countries or whatever, you should be totally fine with. So this is an example of one of the tables that pgRouting sets up. You can see in there, this is the representation of a point-to-point route. So this is, it has the source point, it has the target point, and it also has things like cost data in there. It's got the one-way data in there, speed data, and it's a very extensive system for actually analyzing the most optimal route. So anything to do with sort of traveling salesman problem, this kind of stuff helps you out. So our last point of the day here, how are we going to actually create that route from the function? So all we need is our home base. We have our coordinates, we put those in before. We have our target, which is the charging station that we want to go to. We're going to take that data and we're going to give it to the Dijkstra function. So basically, the Dijkstra function uses Dijkstra's algorithm of calculating the optimal route between two different points. That's all written into PostGIS. So no need to do any of those calculations yourself. You can literally just give it the data and it'll do it for you. So let's see what that's going to look like. So this is the query. Again, it's a lot more simple than it looks, I promise. You can see in there we've got the point-to-point data, we've got the source data, we've got the target data. We feed that in and we're asking it to bring us back the actual route. So what that's going to do is it's going to bring us back a list of line string data in order which sequence will create the route from the point to the other point. So this is creating a new table that's going to be populated by line string data. So let's have a look. So what we're going to then, when that data is in the table, we're going to have to convert that again to GeoJSON data so that we can represent it on that leaflet layer. But again, this is super simple, just using the native PostGIS functions, and it's going to spit out something that looks like this on the bottom. So you can see, again, GeoJSON is very easy to read. You've got a point that goes from certain coordinate to another coordinate through this one, and there you go, super easy. So let's have a look what that looks like in the actual layer. So I'm going to go down here a bit, go past our lovely data before. I also will not be taking any criticisms about the different formatting of GeoJSON data in my file, so no thank you, not interested. So let's just get those comments out of there. So this is the line string data that's going to create that route. So you can see that I've imported that into this file. I'm going to go down here, there's 183 steps. Just before I do this, I should note, bear in mind this has put in the data for this whole area, for all the points, all the ways of getting between those points. It's a huge data set. This query brought that data back in under a second to give me this route. So it's pretty good to go, I would say. Alrighty, let's save the file. Off we go. Back to our map. And now I'm just going to refresh that data again. And there we go. We have a route on the map. Now, again, if you wanted to do this in an interactive way, you could then import that data to some kind of, interactive instruction set. Again, we're not trying to rebuild Google Maps, but again, this is just an example of the functionality that is available with open source Postgres and PostGIS and pgRouting. I will say to you guys, if you look very, very closely here, you can see, and I have to excuse this, we are in fact going to be driving our electric car straight through the middle of a park. So I don't know how you guys feel about that. I don't mind taking a small one through the park maybe. The reason for this is that You can choose whether you want a cycling route, a walking route, or you can have a driving route. That's all built into pgRouting as well. But I've just done a very, very simple example here. And hey, sometimes, we like to live life on the edge. Drive a car through a park, why not? Give it a whirl. So that's just a little kind of small demonstration of some of the stuff you can do with Postgres and PostGIS. Again, as I said, like 5, 10, 15, 25 times now, this is all open source. Like, ArcGIS licenses cost an absolute fortune. Oracle Spatial costs an absolute fortune. You can do all this yourself with Postgres and PostGIS. It'll cost you exactly bagel. Absolutely nothing. So a couple more things about PostGIS just before I finish up. Nearly done here. So we're going to go with integration. So PostGIS will work with KML and MVT. You've already seen the GeoJSON stuff. What this basically means in a practical sense is it means that you don't have to have a translation layer between your application and between your spatial data that's sat in your database. PostGIS does all of that part for you. The other point I've made here is just about the data types. So I've only shown a few little bits and pieces today. PostGIS has full support for 3D. Full support for 3D data types, which is massive. Even I make a joke, even 4D data types, 4D, what the hell's that? It's not time, interestingly. It's if you want to put any metadata into there. So for example, mining companies looking at depths of certain materials, you can tag metadata in there as well. It's very flexible. You can work with both vectors and rasters simultaneously. Probably doesn't mean a lot to too many people, but for spatial data people, that is absolutely massive. It's self-tuning with its spatial indexing, the stuff that I showed today. OSM's pgSQL puts data into PostGIS. It builds the indexes automatically, so the data retrieval is really, really fast. It's all based on bounding boxes and R trees, so when it changes, it's self-tuning in that sense that the trees are self-balancing, which makes it even more performant. And the last point is, it's backed by Postgres. So, as I said before, such a massively powerful, performant RDBMS these days. And I will say it for the final time, it is open source, all super available for anybody to use. And that is about all I've got for you today, guys. If you want a friendly chat or an unfriendly chat about Postgres, I'm here. Thank you so much. Cheers.